3, 2, 1. So today we got a delta math. We are still on exponential growth and decay. Okay. So growth and decay by percentage form. That's something I showed you yesterday. It looks something like this. Blah 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 blah. Okay. Yikes. That's okay. Dead it. I'm sorry. I am the funniest. I am the funniest man in the world. Okay. I love me. All right. So this R is just the percentage, however much is growing or decaying. If it's a decay, it's minus. If it's a growth, you add to that 1, okay? All right, so the first example, an element with mass 140 gram decays. So we'll stop right there, okay? And I'll show you what that 140 stands for. 140 is the A. Ooh, and then it says decay, right? So then in that case, I'll just make it minus.
What is percentage?
Percentage? Percentage. It's like a math term. It's like a math term. Oh, I mean, that's like a fancy way of saying percentage, okay? But for you normies, I'll just put percentage. For you normies, I'll put percentage. You know, that's like an academic term for percentage, but I just forget sometimes where I am. I'm sorry. All right, so you see how I'm filling up the equation from the original equation? I got 140 with the starting amount. See, in the word problem, the element with mass 140, that's what you start with. And then I'm filling out the rest, okay? Decays, all right, so I did 1 minus, I didn't do plus. And then there's my percentage right here, 21.6%. So this as a decimal, we have to convert to a decimal, is 0.216. So I'm going to put it right there, subtracting from the 1. How much of the element is remaining after 20 minutes to the nearest tenth of a gram? All right, and then the T here is the time. So in our situation, we got 20 minutes, so we're going to put 20 right here. So boom, here's the what? Using the equation form, we plugged in the numbers, and what is it asking? It's asking you to evaluate that, and you got your answer. So I don't know, I would just put this in the calculator. 140. I could clean it up a little bit. 1 minus 0.216. Yikes. 1 minus 0.216 is 0.784. Just clean up a little bit, but the rest is just calculator. All this is just calculator business. Raised to 20. Apparently, I'm left with 1.08 grams. Oh, to the nearest tenth. Sorry, so 1.1 grams. So just following the equations format, there I used it. Notice it was a decay. Notice how the starting amount, 140, I replaced it with the A. And it's all very doable, you know. All right, how about the second part? A town has a population of 14,000 and grows at 3% every year. So using the format of the equation, y equals, your starting amount is 14,000, yes. 1 plus or minus? Plus, because it says grows.
It's not 0.03?
It is 0.03, very good. Oh, because that was 21. So when you move it 2 decimal points to the left, it'll be 0.216. But if you got 3% and you move 2 to the left, there'll be a 0 in front of the 3. Yeah, little thing to be careful of. If you put 0.3, that means 30%. If you put 0.03, that means 3%. So here we are. what will be the population after 6 years? Well, t is right here. But instead of putting t, we have the number of years we're evaluating for, so put 6 there. Clean this up a little bit. You don't have to if you got the calculator, but just to make it look nice, you got 1.03 raised to 6. So put that in the calculator. So in this word problem, 14,000 population grows to 16,717. Round to the people. Yeah. Well, that's how you do it. It's all very doable. Make sure you get your grade in by knowing how to do it. And that's what we come here for, you know. So it's pretty doable, you know. But if you're missing something, it's not because it's hard. You just got to ask the right question, so you will understand. So both of these were percentage problems. Notice how if this number, if it's minus, it becomes less than 1. So your answer ends up a smaller number. You start with 140. When you multiply by this, you end up with 1.1. You decay. And look, this is plus 3%. So when you start with 14,000, it's definitely going to expect it to grow up to 16. So if it's a number above 1, it's going to grow. If it's a number less than 1, it's going to decrease. So moving on. But concentrate, make sure you understand this format here of the equation of growth or decay. By a percentage, you see? R is that percentage. You add it or subtract it to the 1. Now these two are a little different. It's not a percentage increase or decrease. So let's read. A new car purchased, we'll just read it first. A new car is purchased for $25,000, and over time, the value depreciates by 1/2 every 6.5 years. So there's no percentage going on here. So the format, the form of the whatchamacallit, it changes to this, or let me make it T. See, it's very, very similar. It's just that you don't have 1 plus or minus a percentage. So it's just one number instead of. So it's actually a little easier, you'll see. And why I know I'm using that, because there's no percentage here. So I'm going to use this number, 25K. Depreciates by 1/2. What does that mean? It goes down by 1/2. So 25,000 times what? 1/2. So your A is 25,000. What are you multiplying by each time? 1/2. So it's as simple as that, and raised to T. T is your time. So we got our equation. And notice how it's similar to the percentage equation, but it's a little simpler because there's no percentage. You just, what are you multiplying by? Here, apparently, it's 1/2. And another problem might be quadruple, so you multiply by 4. But there's the general format of the equation. Now you can use that to answer whatever question they have, they're going to give us. Whoa, okay. Depreciates by 1/2 every 6.5 years. After 6.5 years, it goes by 1/2. Well, I don't like this question all that much.
Which one are you looking at?
The second one or the first one still?
It's in my examples. Oh, the first one up there. What is the value of the car 29 years after its purchase?
It's going to be 100 times 4. It's going to be the last one.
100?
Times 4.
Are you looking at the second one, huh?
There's two different.
Oh, yeah, I'm sorry. I wasn't really finished with the first one. Well, let's just stop there because I might have to change the delta math up a little bit.
For the one for today?
Yeah. Hopefully we didn't all start. What?
I finished.
What? Yeah. Well, let's move on. Okay, this is an important question. In a lab experiment, a population of 100, I'm sorry, a population of 100 bacteria is able to quadruple every hour. Boom. So here's the equation, y'all. 100. Quadruple means times what?
4.
4. So raise that to t for time. There's your equation. But the question is, which equation matches the number of bacteria in the population after 7 hours? So you want an answer that has this equation, but the t is 7. So that's this one. Boom. We're
That's
geniuses.
definitely wrong, whatever you said.
But
That's definitely
I
wrong.
feel
It's
right.
definitely
I
wrong.
feel right.
Oh my gosh.
It's this one, y'all. Feelings are valid. All right, y'all. Delta Math, and like I said, I'll make all the assignments their own grade, so avoid zeros,
Oh my
because I love you.